March of 2004, a test plane mounted on a rocket carried aloft by a bomber made history at Edwards Air Force Base, east of Los Angeles.
Launch.
After release from its B-52 mothership, the small unmanned X-43 flew at the amazing speed of Mach 7, faster than any known jet aircraft has ever flown.
It was a very significant event. Some people have even gone so far as to equate it actually with the Wright brothers' flight.
When it separated from the rocket, the X-43 accelerated on its own power to Mach 7.
Mach 7 is approximately 5,000 miles per hour, so you can imagine flying New York to Los Angeles in just over a half an hour.
The NASA Dryden Flight Research Center says the scramjet-powered X-43 is capable of reaching at least Mach 10. A scramjet is a supersonic combustion ramjet. The ramjet, sometimes called the flying stovepipe, is one of the simplest engine designs ever conceived, with virtually no moving parts. It's basically a hollow tube into which fuel is injected and ignited. Unlike regular jets, there are no compressor blades inside to compress the air. In a ramjet, supersonic air is slowed down to subsonic speed inside the jet engine. But in a scramjet, the air moves through the engine at supersonic speed.
The X-43 vehicle has to endure some very extreme temperatures. The temperature along the leading edges of the vehicle, for example, are in excess of 3,000 degrees Fahrenheit.
The front of the X-43 and the leading edges of the tail are made of carbon-carbon, a lightweight and strong composite material that can withstand extremely high temperatures.
Carbon-carbon that we use is sort of a high-tech cousin to carbon fiber. It's the carbon itself is different. It's a much higher temperature. The bonding agent is much higher temperature. It's good to 3,000 degrees without degrading. It doesn't wear away.
What you see is the front end of the vehicle, the tungsten nose. The very front edge is the carbon-carbon leading edge that provides the thermal protection. As you can see, there's a lot of complicated machinery and very densely packed systems inside this vehicle in order to make it work.
A number of small electric motors on the aircraft are controlled by computer signals from the ground.
Motors on these electric actuators move the surfaces. That's how we maintain control of the vehicle in flight.
Ignition.
Keeping the fuel burning inside the engine at supersonic speeds has been described as trying to keep a match lit in a hurricane.
The flame doesn't really blow out because there are areas in the engine, small areas that aren't supersonic, that allow a flame to grab hold and to sustain itself.
There's something about flying that fast that I think just captures the imagination of folks. It's just phenomenal to imagine flying that fast.
I'd say the main interest you find for the scramjet in the near term would be the military. They would like to have a missile that goes, say, Mach 5, Mach 6, 5 or 6 times the speed of sound, so it can get to a target very quickly and has a lot of range in doing that. You can do that now with a solid rocket motor, but it runs out of gas pretty quickly.
The Air Force is also interested in using scramjet propulsion for super-fast bombers that could strike anywhere in the world with amazing speed, flying more than 10 times as fast as current bombers.
There's no reason that a human couldn't pilot or be a passenger on a hypersonic airplane. Vision vehicles, as we call them, include space access vehicles to take astronauts to the space station or to orbit, and also potentially passenger vehicles, again, to take people to the other side of the world.
Some experts believe the scramjet could usher in a whole new era in aviation.
We entered the 19th century moving at 6 miles an hour, the speed of an animal-drawn vehicle. We entered the 20th century moving at 60 miles an hour, the speed of a steam locomotive. We entered the 21st century at 600 miles an hour, the speed of an intercontinental jet airliner. And if you plot this in semi-logarithmic fashion, you get a nice straight line that indicates we may well enter the next century at 6,000 miles an hour, which is precisely where you see the X-43 really pointing us and heading in that direction.
The X-43 scramjet is carrying on a tradition of cutting-edge aircraft development that goes back decades. And although Mach 7 is a major accomplishment for an air-breathing jet engine, rocket-powered planes were flying almost that fast decades ago. It all began with the most amazing series of extreme aircraft in aviation history. They were called the X-planes, the X standing for experimental. The very first X-plane was appropriately named the X-1.
In 1944, the United States decided to bite the bullet, really, and develop a specialized family of research airplanes, of which the X-1 was first, that would essentially use the sky as a laboratory and which would carry 500 pounds of recording instrumentation and at the same time would also radio very important values that were measured in flight down to ground stations. This marked the birth, really, of a remarkable family of airplanes that continues to the present day, the so-called X series.
The Bell X-1 is arguably the most famous pure research aircraft ever built. Bell Aircraft built 3 X-1 rocket planes for the primary purpose of breaking the sound barrier. For decades, traveling faster than the speed of sound, about 660 miles an hour at high altitude, had seemed an impossible task, hence the term barrier. It literally was seen by many as an impenetrable wall.
This was really brought home in September 1946 when Britain's leading test pilot, Geoffrey de Havilland, the son of the founder of the de Havilland Company, was killed at about 8/10 the speed of sound flying a new swept-wing tailless research airplane called the de Havilland Swallow. The airplane began to pitch violently out of control so rapidly that he could not control it, and within less than a second it had disintegrated and he was killed. This showed that the sound barrier had very real bite.
In 1947, a young Air Force pilot named Chuck Yeager was about to bite back. It would happen at the Air Force Base at Muroc, California, about 80 miles east of Los Angeles. We know it now as Edwards Air Force Base. Robert Cardenas, another young fighter pilot, was officer in charge on the X-1 program, and he piloted the bomber that carried the X-1 aloft.
I had professors from Caltech and MIT that were out there at Muroc. We had all sorts of people making recommendations, and one of them said, you know, really, we've seen stuff coming in from space explode. Whether it was from heat or what, there could be an ultrasonic barrier out there that might just disintegrate or melt the aircraft.
The test pilots and engineers listened politely to the experts and then got down to business. Bell Aircraft test pilot Chalmers Goodland made the first powered flight in an X-1 aircraft in late 1946. But it would be Chuck Yeager who 10 months later would take the X-1 rocket plane to the speed at which it was meant to fly.
Chuck is a human being, but when he gets in that seat and he locks that door, he becomes part of the machine. In my book, he's no longer a human. He's part of that. He melds in as part of that machine.
Man and machine finally broke through the sound barrier in October of 1947. On the ground, observers heard the crack of a sonic boom. Air Force Captain Chuck Yeager and the X-1 had just launched a new era of supersonic flight.
Chuck was the X-1, period. That was it. And I really don't know if anyone else could have done it.
High airspeeds are described in Mach numbers, using a formula named after an Austrian physicist, Ernst Mach. The speed of sound is Mach 1, and Yeager had reached Mach 1.06 on that historic flight. Later generations of X-1 aircraft would fly twice that speed.
Okay, drop it, Daddy. Drop.
In 1953, Chuck Yeager took one of them to Mach 2.44. Many more X-planes would follow the X-1, but none would provide more crucial research data than the X-15. The 3 rocket-powered X-15 aircraft flew 199 flights from 1963 to 1967. Far beyond supersonic, these research planes ushered in the era of hypersonic flight, the term for speeds greater than Mach 5.
We had a 57,000-pound thrust rocket engine that was completely throttleable, the first of its kind, and you had tremendous problems in simply making this a reliable propulsion system. Now, once we did, all speed and altitude records very quickly were eclipsed by this airplane. It went out and immediately took us in a piloted sense to Mach 4, Mach 5, Mach 6.
As rocket planes like the X-1 and X-15 made amazing progress pushing the limits of speed, they paved the way for a new top-secret aircraft that to this day inspires awe, the SR-71 Blackbird. Cloaked in secrecy, two American spy planes, the U-2 and the SR-71 Blackbird, made their mark on history during the Cold War. The U-2 was the first to become operational in 1956. Built originally for the CIA by the Lockheed Advanced Development Projects Group, better known as the Skunk Works, the U-2 could fly higher than any aircraft in existence at the time and provided crucial intelligence on Soviet military activities.
When there was worry that the Soviet Union might be gathering a bomber fleet or might be gathering its forces for an attack on Western Europe or whatever else it might be up to, there was no way, literally, to penetrate this Iron Curtain, say fly over it.
To operate at 70,000 feet and higher, the U-2's jet engine had to be virtually hand-built, with much closer tolerances to reduce air pressure losses at high altitudes. Flying long transatlantic missions alone at night, navigating only by the stars with a sextant, the U-2 pilots collected intelligence that dramatically improved America's ability to assess the Soviet threat.
The U-2 operations really gave rise to some remarkable images. There was imagery brought back that showed Soviet fighters trying to climb and catch it, stalling, spinning out of control, falling to earth, other airplanes trying to do so-called pop-ups to get to altitude. Clearly they knew we were there, but they were very frustrated at not being able to reach us with airplanes.
The long, wide, straight wings of the U-2 gave the plane glider-like characteristics. And it would soar so far above the ground that even if the Soviet military detected it, they couldn't reach it with fighters or missiles. Or so it was believed, until May 1st, 1960. On that day, Francis Gary Powers was shot down by Soviet missiles as he took photos from 67,000 feet. After Powers successfully ejected, the Soviets put him on trial for espionage. The incident severely strained U.S.-Soviet relations. Powers was released 2 years later. Today, high-altitude reconnaissance is done mainly by satellites, but an updated version of the U-2 has provided battlefield intelligence in Bosnia, Kosovo, Afghanistan, and Iraq. It is also being used for high-altitude research projects by NASA and other civilian agencies.
We do earth sciences. NASA has done it for 30 years or more. And that requires overflight over forest fires, over forests, desert, into the Arctic to check on the ozone layer, which NASA first discovered. We fly a bigger variant of the U-2, but we have two of them, and we fly them worldwide on various missions of those kinds.
As effective and enduring as the U-2 has been, it wasn't enough to meet America's reconnaissance needs at the height of the Cold War. Once again, the Lockheed Skunk Works, headed by the legendary Kelly Johnson, was tapped to come up with something better. And in 1962, they outdid themselves. The SR-71 Blackbird, a high-speed, high-altitude spy plane, is revered by many as one of the greatest jet planes ever built. The ethereal Blackbird could fly higher and faster than any jet aircraft in production, and that still holds today.
I knew that this airplane was going to be the fastest in the world. What I didn't know was it would remain the fastest for 40 years. That's astonishing. But I remember back in the 60s, Kelly used to say, and he'd say it kind of aggressively, like, I challenge anyone to adversely comment on this. He says, nobody's going to produce an airplane with greater performance than this one by the year 2000. And back then I used to think, Well, I hope I hang around long enough for the year 2000 to see if that turns out to be accurate, because before this came along, every 2 or 3 years somebody somewhere would produce one faster.
As with the U-2, the initial client was the CIA, not the Air Force. The first version was called the A-12 and made its first flight in spring of 1962. To be able to withstand the heat generated by sustained speeds above Mach 3, the A-12 had to be designed from scratch with new technology and new materials.
We would say this is roughly an 800-degree Fahrenheit airplane. Some things are hotter, but we have some cooler. I understand the self-cleaning oven is around 425 and the soldering iron around 550. So that gives you an idea of what kind of heat we're talking here.
The airframe was made from titanium and titanium alloys, and the structure was coated with a special radar-absorbing black paint that helped dissipate the heat. Because the aircraft surface was designed to expand from the heat during flight, the plane would leak fuel while sitting on the ground. The expansion would cause the entire aircraft to grow a couple of inches in length.
This is the ejection sequence initiator, and you're flying along and the canopy is closed, and you want to get out, so you pull this thing up. The first thing that happens is this canopy goes, and then up you go, and as you come out you turn like this, and then you're dynamic this way, and you deploy a stability chute, a small chute just for stability, and the G's may knock you out, but it won't be death concern on that. And as you're coming down you may still be unconscious, and then when you hit 15,000 feet, it cuts away that baby drogue chute for stability and deploys a large 35-foot chute.
The aircraft was about 100 feet long and could carry 20 tons of special JP-7 jet fuel in the fuselage and wing tanks, enough to fly for about 2 hours. During this time, the high-flying spy plane could survey about 200,000 square miles of the Earth's surface. The CIA's highly classified single-seat A-12 version first flew in 1962, and the Air Force's twin-seat SR-71 version first flew in 1964. The two planes were nearly identical, and both could fly faster than Mach 3 at heights above 85,000 feet. The CIA continued to fly the A-12 until 1968, when the Air Force Blackbirds, based at Edwards Air Force Base, took over their reconnaissance duties. It wasn't only the fastest and highest flying airplane of its day, it also pioneered what today is called stealth, the ability to evade detection by radar.
That airplane has these very, blended shapes and sharp chines, and it's got the tails folded in and so on. And they, did not much by calculation, but a large amount by intuition and by taking it out to a radar range, sort of the equivalent of a wind tunnel for radar, with models and trying different shapes and so on. And basically, by the time you saw the thing on radar going at Mach 3, it was gone.
But now the Blackbird really is gone. The military mothballed the SR-71 fleet in 1990, claiming satellites could do the job better. 2 of the Blackbirds were temporarily reactivated in 1995. Before there ever was an SR-71 Blackbird, another, even more futuristic-looking aircraft was being tested at Muroc. And this one was so far ahead of its time, it would have to wait decades before aviation technology caught up with it. Flying Wing says it all about the appearance of 2 of America's most futuristic-looking bombers. One from the past, and one from the present. Although separated by nearly half a century, they have exactly the same wingspan and were developed by the same company. The original Northrop Flying Wing bomber first flew in 1946. Its contemporary counterpart, the B-2, had its first flight in 1989 and will probably still be flying decades from now. Aircraft pioneer Jack Northrop was a champion of the flying wing design, which eliminates the standard fuselage and tail found on most aircraft.
Northrop, who was a consummate master of aircraft design, the most important designer of the interwar period in the United States, not just because of his flying wings, but because he's taking all the cutting-edge developments in high-speed aerodynamics and streamlining, and he's putting this together. Northrop felt the next logical step was the pure flying wing. This became almost an obsession with him.
In 1941, Northrop was awarded a contract to develop and build the XB-35 flying wing bomber, capable of carrying a bomb load of over 52,000 pounds with a range of 7,500 miles. World War II was over by the time the XB-35 first took to the air in 1946, powered by 4 piston engines. The following year, the YB-49 flying wing with 8 jet engines made its first flight. Air Force Major Robert Cardenas, the officer in charge of the X-1 project, was also chief test pilot for the YB-49 flying wing. Because of the plane's unconventional flight characteristics, Cardenas was nearly killed when he tried to put the flying wing into a stall during testing.
When you start slowing down, there's one point at which the airflow over the wing ceases to create lift and you quit flying. And it shudders and it shakes. That's a stall. But I was waiting for the shudder, and instead of that, it just gave kind of a lurch and it went over backwards and started tumbling backwards. So I reached up and I hit the left throttle full power on the left side. Even though it was tumbling, this side went up, tumbling it over into more of an inverted spin, and I could get out of that.
Although Northrop insisted the flying wing couldn't possibly tumble, Bob Cardenas knew it could. And he warned his good friend Glenn Edwards, another test pilot, about the problem. Cardenas was apparently proven right by a tragic accident in 1948 that killed Captain Edwards. Edwards was testing the flying wing when it crashed for unknown reasons, killing all 5 members of the crew.
I think they were stall entry maneuvers, and maybe they entered it at a little higher speed than I did, because on that first lurch where it goes over backwards, the load is on the wing like this kind of a load, and that's what broke off. The wings broke off outboard of the jet engines.
The last thing Edwards wrote on his notepad indicates he may have put the airplane into a stall, in spite of the advice he got from Bob Cardenas.
One of the things that they had found was one knee pad card, which said stall entry maneuvers.
The accident would change Muroc Air Force Base forever. It was renamed Edwards Air Force Base in honor of Cardenas's friend and fellow test pilot. In spite of severe problems with the aircraft, the YB-49 flying wing program continued, and Cardenas was developing strong misgivings.
I did not want them to buy the airplane.
Nevertheless, in 1949, one of the planes set a new transcontinental speed record when Major Cardenas piloted a flying wing from Muroc to Andrews Air Force Base near Washington, D.C. in 4 hours and 20 minutes. President Truman was there and was favorably impressed.
Truman came up in the cockpit and he looked around. He was a pretty crusty old guy. He used a little more foul language than I'm going to say. He said it looked pretty damn good to him. He said he's going to buy some. I bit my tongue. Then down on the ground, he turned to the Chief of the Air Force and he said, why don't you have this young whippersnapper fly this down Pennsylvania Avenue? Rooftop level, I want people to see what I'm going to buy. So I did. I slowed down. I slowed down to about 300, 350 knots. But I had never really realized how heavily forested the city of Washington really is. It's a jungle. Well, while going down the avenue and losing the avenue amongst the trees, all of a sudden I looked up and the Capitol Dome was straight ahead. So I had to pull up to go over it. Somebody on the steps took this picture as we were going over the top.
The ill-fated trip back to Muroc would help bring the troubled flying wing project to an end. During the flight, 6 of the bomber's 8 jet engines caught fire, forcing an emergency landing in Winslow, Arizona. Later that year, the Air Force's order for 30 flying wing bombers was canceled. But the Northrop Company wasn't finished with the flying wing idea. By 1981, aviation technology had changed dramatically, with electronic fly-by-wire controls making a flying wing design much more feasible.
Fly-by-wire is basically computer controlled. There's no hydraulic or cable linkage to the controls. The computer is monitoring what you want it to do and adjusts the flight controls in accordance with what you're asking the airplane to do.
Northrop Grumman won a contract to build the Air Force a new bomber that would use Jack Northrop's flying wing concept. Apparently, Jack Northrop got the dimensions right the first time. The new flying wing, called the B-2, would have exactly the same 172-foot wingspan as the old flying wing.
The build of that wing was a very, very challenging activity for us. The team overcame day in and day out. We used to call it an invention a day to get us through the day. And it's probably as exciting a time as you'd ever come across.
It's a very highly integrated aircraft, very complicated, very complex. She's a very smart aircraft. Once she's all put together, you can't do anything to her you're not supposed to. She'll let you know.
Jack Northrop, who was still very alert and very much interested in flight, had the chance, shortly before he died, to learn about the existence of the B-2 program. And he was very touched, and he said now he knew why God had let him live as long as he had.
The B-2 stealth bomber was first revealed to the public in 1988, when it was rolled out of its hangar at the Air Force's Plant 42. To many, it signified that the flying wing design had finally become a successful bomber.
To me, it was vindication for Glenn's death. My work and his death were not in vain. We did accomplish something. We didn't do it, but somebody accomplished the final act of making a system like that.
The B-2's first flight came the following year, with test pilot Bruce Hines at the controls.
When Bruce Hines was going to fly it, they asked me to talk to him. I told him, I can't tell you anything. It's a different airplane. Just one thing, Bruce, don't stall the airplane. And so after he flew it, I said, Bruce, did you try stalling him? He said, Bob, the damn thing won't let you. It won't let you stall it.
The first production B-2 was delivered to the Air Force in 1993. The 69-foot-long bombers are powered by 4 jet engines and carry 2 pilots. They're designed to carry 40,000 pounds of conventional or nuclear bombs and can fly at altitudes up to 50,000 feet. B-2s are subsonic, which means their top speed is just under the speed of sound. The fleet of 21 B-2s based at Whiteman Air Force Base in Missouri first proved itself in combat in Kosovo, where B-2s destroyed more than 30% of Serbian targets in 8 weeks by flying non-stop missions from Missouri to Kosovo and back. The B-2 is much more technically sophisticated than America's other long-range bombers, the B-52 and the B-1.
The B-1 as well as the B-52 are not stealthy platforms. Only the B-2 bomber can penetrate heavily defended airspace, fly for thousands of miles undetected, carrying a huge load of weapons, deliver those weapons precisely, and get out of that area without being detected.
Jack Northrop would be more than proud, and proud of the people every bit as much as he's proud of what the people have done with the technology, and certainly some of the very basic vision that he had years and years ago.
With the B-2, the U.S. Air Force unquestionably has the most modern bomber in the skies. Now, they need a fighter to match. Enter the F-A-22 Raptor. The McDonnell Douglas F-15 Eagle first flew in 1972. And reigned unchallenged for decades as the world's premier air superiority fighter. But the new F-A-22 Raptor will finally bring that reign to an end. Both the F-15 and the Raptor fly and climb faster than conventional jet fighters. This enables them to dominate air-to-air battles with enemy planes, which means they can deny the skies to the enemy. Hence the term air superiority fighter.
The goal in developing a fighter airplane is really to make certain that you can totally, overwhelmingly dominate the opponent. If you look at the F-15, it became America's most successful air combat fighter. Indeed, you can argue historically it's the most successful air combat fighter of all time because it has never been shot down in air-to-air combat while shooting down close to 200 opponents in air-to-air combat.
In 1975, 20 F-15 Eagles were modified to make them even faster. Called Streak Eagles, they set several time-to-climb records that still stand. But the new FA-22 Raptor is expected to break those records and bring new meaning to the term air superiority.
The F-15 is very old in the tooth. You know, if we take a look at our fighter forces today, you realize that if these airplanes were automobiles, they'd be wearing classic car plates.
After a testing and validation program lasting 4.5 years, the industry team of Lockheed Martin and Boeing in 1991 won the competition to build the next generation air superiority fighter that would replace the aging fleet of F-15s.
It capitalizes on a number of technological revolutions, and this enables us to get first look at an opponent, first shot at that opponent, and first kill, where we are literally moving out of the fight before the enemy realizes they're being attacked.
You can detect him, you can fire a missile on him, and he'll almost blow up before he even knows you're there. So it's not that you're undetectable, but by the time he does detect you, you already have such an offensive advantage on him that it's really not even a competition.
The production version of the F-22 design, now called the Raptor, first flew in 1997. Like the F-15 Eagle, it can reach supersonic speeds. But the Raptor can cruise without using fuel-hungry afterburners, giving an enemy less time to engage it. The F-A-22 is also easier to fly.
An Air Force pilot who was training to fly the F-A-22 told a bunch of reporters recently on the trip that I took that traditionally a pilot had to spend about 85–90% of his or her brain power just to attain a situational awareness, just to take the information from each of his sensors and understand what they were telling him. He says with the F-A-22 Raptor, that situational awareness is almost instantaneous, so he has most of his brain power left to devise how he's going to attack a certain target or how he's going to evade something, that type of thing. So that's a real significant difference.
Another capability that gives the Raptor an edge is thrust vectoring, a system that allows the blast of hot gases coming out of the engine to be pointed in different directions. This allows the aircraft to change direction much more rapidly than conventionally powered fighters. Thrust vectoring was pioneered on the X-31, a NASA research plane built by Rockwell. The X-31 put on a dazzling display of thrust vectoring capabilities at the Paris Air Show in 1995.
Most people at the air show in Paris when they first saw that thought the airplane was going to crash. And then it just flies right on out and goes and does another maneuver. These people had never seen it were just in awe.
The X-31 helped pave the way for the F-A-22 Raptor's use of the thrust vectoring concept.
The maneuverability of the F-A-22 in a dogfight is such that if you're in the merge and you're doing that spiraling telephone pole of death, you know, where you're going down, descending, losing altitude, and trying to outturn the other guy, with the F-A-22, with that thrust vectoring, it allows you to put the nose right at the guy and fire a missile and end the engagement.
You initially try to start fighting just like you did in an F-15, and then you start to realize what capabilities you have and what limitations no longer apply to you. So you adapt real quickly, but it doesn't take someone very long. After a sortie or two, coming from the 15 into the F-22, it's an awesome capability.
The F-A-22 is also stealthier than any other jet fighter, including the F-117 stealth fighter, which represents an older generation of stealth technology.
That's not very stealthy, right? But head on, you don't see much of the jet, and you don't have anything hanging on the wings to give your signature away. And so we like to say, beware of Raptors with open doors. You know, when the doors are open, that means that you're shooting something, and the doors open quick, shoot something and close before a radar signature gets transmitted back to the enemy. Even when the doors open, now suddenly you have sharp corners and weird angles, and that can reflect radar back in a direction you don't want to.
The Air Force plans to eventually purchase 339 Raptors, and production of the aircraft is scheduled to continue to 2013. The FA-22 is an Air Force pilot's dream. But there are planes on the horizon that may be more like a pilot's nightmare, because these aircraft have no pilots. The Global Hawk spy plane points the way to what some believe will be a pilotless future. This UAV, or unmanned air vehicle, was seen in action by millions thanks to TV news coverage of its surveillance missions in Afghanistan and Iraq. The Global Hawk can conduct effective surveillance over an area the size of Illinois in just 24 hours. It can also loiter above a specific area, transmitting almost real-time high-resolution images to field commanders. 44 feet long and 15 feet high, the high-altitude reconnaissance aircraft was built for the Air Force by Northrop Grumman.
Global Hawk is an autonomous air vehicle. For instance, when Global Hawk did a deployment to Australia, the Global Hawk left California with a click of the mouse. It is fully autonomous, and then it flew across the Pacific Ocean and landed in Australia some 20-odd hours later, at which time somebody clicked the mouse again and shut the engine down on the system.
With its range of more than 14,000 miles and an ability to fly for 36 hours straight, it can travel to any point on the globe, conduct surveillance, and return to its base in the United States, all without a pilot. The Air Force rushed the Global Hawk into combat ahead of schedule in Afghanistan in November of 2001, and it was also used in Operation Iraqi Freedom. Although it flew only 5% of the surveillance missions over Iraq, it accounted for more than 55% of the information on time-sensitive targets, many of which were destroyed. After collecting more than 3,700 images over Iraq, the Hawk returned home in May of 2003. Air Force officials said the Global Hawk was over Iraq from the very beginning of the operation and had a direct impact on the Republican Guard's destruction. Although most use of UAVs so far has been for reconnaissance, there is growing interest in putting weapons on them. The Unmanned Combat Air Vehicle, or UCAV, is seen by some as the top gun of the future. One of the most dramatic first uses of an armed unmanned aircraft in combat came during Operation Iraqi Freedom, when Predator reconnaissance drones were outfitted with Hellfire missiles.
There's one famous mission that the Air Force likes to talk about during Iraqi Freedom. There was a broadcast tower from the Iraqi Information Agency in downtown Baghdad, and that tower was very close, I believe, to the Fox News tower and also to a mosque. And so it was a very, very dangerous target for the Air Force to go after. So what it did was it sent a Predator unmanned aircraft armed with Hellfire missiles into downtown Baghdad, and the remote pilot who was operating the aircraft from thousands of miles away in the ground control station was able to pinpoint that tower and actually take it out without any collateral damage to the Fox Tower or to the mosque.
The Air Force is now testing the Boeing X-45 UCAV demonstrator, which first flew in 2002.
The X-45 is the first unmanned aircraft that has been designed from its inception to be a combat vehicle.
Mark impact.
A larger version, the X-45C, is the precursor of Air Force UCAVs that will become operational in 2010. The X-45C will be nearly 40 feet long, with a wingspan of nearly 50 feet. It will be able to carry 8 GPS-guided bombs, weighing 250 pounds each in its internal weapons bays. Northrop Grumman is also testing an unmanned combat air vehicle. the X-47A Pegasus. It was designed as a flight demonstrator for the X-47B that could be used by the Navy.
Pegasus was our UCAV demonstrator. It was a company-funded investment. The way we approached the Pegasus was basically to demonstrate that, in fact, you could take an unmanned combat air vehicle and land it on the deck of an aircraft carrier.
There is still some debate, even within the military, about how and when UCAV should be deployed.
I think there's just this sort of rules of the game, ethical bridge to be crossed of, is it okay for a drone to be, and firing, and are we really sure that that's Osama and, not the head of the orphanage who's walking along the street? There's a lot of, queasiness about doing this. Because, you're looking through a soda straw on these things, and, are you really sure that's the guy? The chances of making a mistake are pretty high, and you really obviously don't want to kill innocent people.
We must be very, very careful that we don't develop systems that are so complex that they really transgress whether or not they should be inhabited systems. There's a tremendous value in having the inhabited system because, to be frank about it, an inhabited aircraft carries with it a great deal of innate common sense that sometimes you don't have in a system that's relying on the lineup of ones and zeros.
It remains to be seen how commercial airline pilots and private pilots will feel about sharing airspace with planes that have no pilots.
Years ago, if any one of us got into an elevator, there was an operator, an attendant inside the elevator. Today, I certainly don't see that person in the elevator anymore. You get at many airports today, and you want to get to another terminal. You get on an unmanned train, and we accept that. It's normal. That's going to take place with UAVs for sure. The technology is there, the will is there, and it's now just a matter of time.
As aircraft technology continues its flight into the future, exciting possibilities are opening up that could change our lives and bring the world closer together, just as the jet age did.
The challenge for us today is to capitalize on some of these new technologies, and if we seize on that, we will indeed have, I think, a high-speed future. But if we do not, that future will be in the hands of other people.
America's very first jet, the P-59 Aerocomet, took off and flew into the future more than 60 years ago. It was a dramatic new concept at the time, but it soon became commonplace and unremarkable. Perhaps 60 years from now, combat jets without pilots and scramjets that fly at Mach 10 will be considered commonplace and unremarkable too.
Ignition.
Nevertheless, there will always be some aircraft defined by the term extreme.
Look around you. Are things really as they seem? Could it be that the dark